Howdy folks, and welcome to another technical tutorial on the Decision Server Insights product. In this tutorial, the goal is to walk through a demonstration of the product that IBM is using to illustrate some of the capabilities. So this is a demo which is delivered as part of IBM's Proof of Technology or POT education class, and during that class students get the opportunity to build it out and understand it in great depth. The demo also is a particularly good way of illustrating the capabilities of the product, so we're going to walk through the execution of the demo here so that an interested party can see the demo in operation, and if desired, be able to give it themselves. So within the demo there is a Java application that is called the Banking Scenario Client, and we'll go ahead and we'll launch that as a Java application. It takes a few moments to start up. Now, what this client application does is pretend to be either a mobile phone or an ATM machine. So this is a banking demonstration, and when launched, the application allows us to start instances of pretend ATMs or pretend mobile phones. So if I click the Launch Mobile button, up comes a simple emulation of a mobile phone device. And here we can pick cities where the mobile phone might be located and individuals who might be the owners of the mobile phone. And then from the phone, you could imagine that they could click buttons in the relevant applications, for example, to check an account or call a bank. So with those notions and the understanding that this application is an emulated client that is sending events into DSI, let's walk through the recipe or the script of executing this demo. So first of all, we're going to, as the user called June in New York City, click the Check Account button. So we click on Check Account and June gets her bank balance. So not a very exciting demonstration, but what we're illustrating here, and shortly I'll show you the rules behind it, is that when a check account event comes in from June in New York, her balance is shown. Well, that's very good. So now let's run this again as the user called Tonya, also in New York. We execute the Check Account button, and this time Tonya gets her balance, but she also gets a promotion advert on her phone. Since she's in New York, she's invited to come and see a Broadway show. And again, when we get into the rules in a few moments, we will see how that happened. Well, that's pretty cool. That's pretty nice. So let's see what else we can do here. So with David in San Francisco, David can run his check account, and he gets a promotion that he's in San Francisco. Oh, that's cool. That's cool. Well, let's look at the ATM now. So here's our friend Dave, and Dave is going to be in San Francisco, and Dave's mobile phone is also going to be in San Francisco, and Dave withdraws $100 from his ATM and receives an advert on his phone saying, "Would you like to see a guided tour of San Francisco?" And again, these are events. One is generated from the ATM here, and the other one is received by his mobile phone. That's pretty cool. And but again, before we get into the rules, let's look at another usage. So let's go back to Tonya, and Tonya again is in New York, and Tonya checks her account, and she sees an advert for a Broadway show. Now let's say a few minutes later she checks her account again, and this time she just gets her bank balance. Notice that there is no Broadway show being shown to her. Okay, that's cool. And the last thing I want to demonstrate here is that if we've got a user called D in New York, and D checks his account, Dee's native language is Chinese. He sees his messages in Chinese, whereas Francis is French, and Francis sees his messages in the French language. All right, I guess the French language is called French. There we go. So we've seen here some of the demos of DSI in operation, and at this point you just have to trust me that DSI is actually running under the covers. So now let's go and have a look at the rules that we're executing to make this happen. So we got a set of rules here, which we're calling our recommendation rules, and what these rules say is when a banking event occurs, for example, a request to check your bank account, when a banking event occurs, these rules are executed. And the rule here says, if all of the following are true, if the person has a propensity to be interested in Broadway shows, and the city of this event is either New York or Newark, and today is after this particular date, and they haven't seen or they haven't had any other recommendations presented to them within the last 30 seconds, then send them an event which will cause a promotion or a recommendation for a Broadway show to appear on their screen. So again, these are the business rules defined in a natural language. So that's pretty cool. So in principle then, if we say he's in Hartford and Francis checks his account, he doesn't see any promotion. Why doesn't he see any? Because he's not in New York and he's not in Newark. Makes sense. So if he's in New York and we check his account, he sees a show. Yep, because he's in New York. But now if we check his account again, he doesn't see the advert. Why? Because he had a product recommendation in the last 30 seconds. If we waited 30 seconds from now, he would see another promotion shown to him. Let's try that. Check event. Nope, we're still too early. The propensity for Broadway shows, that could be handled by a decisioning engine. But basically that says, has he bought musical items within the last 80 days? And for our subjects, that's going to be true. And we also have the notion that the entity, which represents our customer, has an attribute called their preferred language. And the preferred language of that entity, of the client here, which is performing the check account, that is what is sent to as part of the emitted event, and that is used to choose the correct language from which the information is shown to the individual. So let's go back to Tanya. There we go. Tanya. Boom. Now there's another set of rules here, and this one's to do with San Francisco. And that basically says that if the event comes from anywhere in the state of California and we haven't recommended to somebody in the last 30 seconds a promotion, then they will see a guided tour request for San Francisco. That really only makes sense if they're in the Bay Area, but there we go. So here, very simply, we've illustrated some of the rule processing. Oh, and of course, the devices which are receivers and emitters of events don't have to be the same. So here we've got an ATM with Tanya in San Francisco, and if Tanya withdraws $100, no, that's not going to work. We've already done Tanya at least recently. Let's use David. If David withdraws $100 from an ATM, that's a banking event, and the emission of the outgoing event would be targeted at his mobile phone. So again, we're seeing a kind of a disconnect here, deliberate disconnect. So an event happens for David in San Francisco on one kind of device that can be transmitted to a different kind of device. Okay, so that's the end of this part of the demo, and in a few moments we'll carry on to the next part. Okay, so now on to the second part of our demo. In this one we're going to talk about customer retention. So in this story we're going to have two mobile phone devices. So let's open up a second mobile phone. And let's open up one mobile phone for Francis in New York. So here's our friend Francis in New York, and for Tanya also in New York. Hello, Tonya. All right, so let's have both of these users check their accounts. So here's Francis in New York, and here's Tonya in New York. So both of them submitted balanced queries. Both of them were determined to be in New York, but Tonya here, she gets offered a free dinner on Broadway. Well, that was nice of us. So why did Tonya get offered a free dinner and Francis here didn't? Well, in this story, we're telling or we're modeling the notion of churn prevention. And the idea behind churn prevention is that we may have customers of our bank who we consider to be either high risk for leaving the bank, or we consider them to be highly profitable. Either way, they are customers that we do not want to lose as customers. So when we recommend a show here, then the rule asks the history of this customer, asks, are they platinum or gold, and are they profitable? So here we go through a scoring engine, and we try and determine whether the customer is at risk for churn and is a platinum or a gold customer. And if the customer is considered a high-risk customer for loss, and they are profitable, so they're within the 50% over the highest risk for churn, and they have an average profitability which is 30% more than the average customer, then what we'll do is we'll automatically offer them a gift. In this case, it would be a free dinner in Broadway, which of course only makes sense if they have been offered a Broadway show. So here's another example of rules processing at work. So again, let's walk through this rule. So when they are offered a product recommendation, and this product recommendation is a Broadway show, then define the average churn as the definition of how likely we are for a customer to leave us, and define the average profitability as the average profitability of all customers, and then we figure out our client's churn score, and if that's 50% higher than average and their profitability is 30% higher than average, then our business declares that we'll offer them a free gift, which is dinner on a Broadway show. So this pot sweetener, for want of a better word, might entice some of our most profitable customers and some of our customers which are the highest risk for leaving our environment. It may entice them to think better of us if we buy them dinner. Again, that's nice of us. All right, that ends this section of the demo. In a few minutes, we'll get on to the next part. Okay, so now we're going to turn our attention to the notion of fraud detection. So let's close these mobile phones. We don't need those anymore. And let's open up a new mobile phone for, I don't know, let's say June in New York. So June in New York. Now let's say June is in New York and everything's great, and that's wonderful. Now, June in New York, she has a pattern of ATM withdrawals. So maybe on a Monday she withdraws $100, and on a Tuesday she withdraws $100, and then the week later she withdraws $100, and she's really good at withdrawing $100. I mean, that's what she normally takes out. Now let's say June now apparently withdraws $500. So she hits her withdraw button, and look at this. Our rule has determined that this is a suspicious transaction. What makes it suspicious? What makes it suspicious is that this ATM withdrawal does not follow the pattern of what June normally withdraws from her ATM. So let's see how a rule like that might be determined. So that's under our fraud detection story. And here is the rule. So here we say when a withdrawal occurs, this is our ATM withdrawal, then what we do is we calculate the recent transactions during the last 50 days. So we're examining the last 50 days of June's ATM withdrawals. And then we set the average withdrawal to be the average amount you withdrew over those transactions in the last period of 50 days. So we then say, if there were at least 5 withdrawals in the recent transactions, and the amount of this new transaction is at least 3 times more than her average transaction, then emit a new fraud alert. And that's exactly what we see happening here. So June normally withdraws $100. So in our last 5 withdrawals, that's what she's done in our recent history. And then we calculate the average. The average of her withdrawals is $100. And in this one, she withdrew $500, which is certainly more than $300, which would be 3 times the average. And we indicate that as a fraud identification. So here we've got a rule which might be, I mean, it's very simplistic, but it might be used as a mechanism to detect fraud. And again, I encourage you to study this rule and make sure that you understand or can at least comprehend each of the different aspects of it. Pretty cool. All right, in a few moments, we'll have a look at the next demo. Okay, this brings us to our last portion of the demo, and again this one relates to fraud. So let's have a look at our friend here called Shreko. Shreko is in New York, and that's wonderful, and Shreko has his phone based here in New York. So let's check Shreko's account, and we see here that Shreko's in New York and he has a bank balance. He's also a good customer, so he gets offered a Broadway show, advert, and dinner if he decides to take that up. That's great. Shreko is in New York. We know this because at this time his mobile phone identified him as being in New York, and he executed a bank balance query. Now, let's imagine there is a ATM machine in San Francisco. I'm sure there is one. There's an ATM machine in San Francisco, and somebody withdraws $500 from Shreko's account. But wait a minute. Just a few moments ago, we identified Shreko as being in New York, and now we are seeing an ATM withdrawal from what should only be Shreko in San Francisco. Uh-oh, that sounds like a potential fraud problem. So let's have a look at the rule we use to determine that. That's a bit more interesting. So DSI not only can do time-based event processing, but it can also do distance-based calculation. So in this event, what we're saying is that when a banking event, such as an ATM withdrawal, occurs, then we determine the distance and the time between this current event and the last previous event. So we determine how far away the ATM withdrawal was from, for example, the telephone mobile query, and we determine how much time elapsed between those two queries. We then calculate what is the maximum time it would take to fly that distance, what is the maximum time it would take to drive that distance, and we ask ourselves some logic. Could he have driven there in time, or could he have flown there in time as a function of how far away the events happen from each other? And if neither of those are true, if he couldn't have driven and he couldn't have flown, then that's a fraud potentiality, and what we'll do is we'll issue a new event which says that, hey, Shreko, somebody might be using your ATM card in San Francisco while we think you're in New York. Please call the bank. Well, that's pretty cool. Now, Shreko then gets a message, and the message says something like, please call within 60 minutes so that we can check your account. Now, if we leave this for a period of time, what we will see is that that message dynamically changes. What we're doing here is we have one other capability in our story, and that is what happens if the customer does not call back in within 60 minutes. We get a message here saying that the customer should call us back within 30 minutes. So what we're doing here is we're detecting whether or not the customer calls us back within the 60-minute period. So we're detecting the absence of an event. So we're saying here that when a fraud event occurs, when we tell the customer to call us back, and if the customer doesn't call us back within an hour, or in our demo 30 seconds, and we have not heard from the customer, then emit a new event that tells the customer, please urgently call us within 30 minutes. And perhaps if we don't get a response from the customer after this period of time, we might suspend that account until the customer does call us. So in that portion of the demo, we can not only detect the arrival of new events, we can also check for the lack of arrival, or the failure to arrive, of an expected event. Okay, so what we've done here is we walked through the salient points, the important points of a DSI demo that is allowed, or able, not allowed, is able to be built by students during the IBM Proof of Technology. Now, we've just walked through its execution, and we probably didn't take 30 minutes to do that. In the POT class, you get to build out this solution piece by piece by piece, slowly, with instructors there to help you do it, etc., etc. In addition, we can always at IBM, if you walk you through this story in more detail, if you would like to see this demo customized for your own use. I hope you found some value in watching these demos, and look forward for more of them to come in the future. Thanks now, and bye-bye.